Welcome guys, welcome back to the channel. Now today we are going to discuss about the OSPF protocol part 2. So earlier video we have created about the OSPF, which has the part 1 where we have discussed about the basic about the OSPF protocol. So it's time to discuss about the some few terms, and that few terms are what are the different types of packets are available, what are the different states are available, and the advantages and disadvantages, guys. So let's start with the agenda. An actual agenda. So here, very first is what OSPF packets, guys. So here in OSPF protocol, we have 5 types of packets. Very first is a hello packet. Second is a database description packet. Third is a link state request packet. Then fourth is a link state update packet, and the link state acknowledgement packets. These are the 5 packets are available in OSPF packet. And this is what the core of OSPF working. How OSPF protocol is going to work. That things are going to be managed by the OSPF packets. So the text very first is what the hello packet, or we can say link state advertisement packet. So this is what the alternative name. So as you know, guys, the OSPF protocol is going to be used for the very large network. So here we need to understand, we need to discover who are our neighbors. Very first purpose of hello packet is what? To discover the neighbors is what the hello purpose, hello packet purpose. Before the router can flood all the routing in flood all the other routes with the information about its neighbor, it must greet its neighbor. First of all, it must greet its neighbor. What are the neighbors? How many of neighbors are available? Okay, it must know if they are alive in order to check whether they are live or not. So again, the hello packet is going to be used, and it must know if they are reachable to the OSPF, and use the hello message to create neighborhood relationship and to test the reachability of neighbors. So ultimately, or moreover, we can say the hello packet is going to be used for the discovery of neighbor. If not, before they generally they greet to the neighbors and they check whether they are live or not. If they're live, then it's build the neighborhood relationship, and again check the relationship is reachable or not. Okay. If you go with the diagram, guys, here I have shown is the router 1 and router 2. The router 1 and router 2 generally send the hello packets to each other. Very first state, R1 will send, then R2 will send. Then only if both exchange the hello packets, then only neighborhood relationship is going to be maintained. So there is one format, guys. Format to hello packet. What kind of information is going to be sent? So header format. Here header format is what type 1. Here showing type 1 because we are taking about the type 1 packet format packet. Okay. Then header format. It comprises of network mask of the advertising OSPF interface. Which interface is going to be advertising all these things that network mask supposed to be given. And for unnumbered point-to-point interface and virtual link, it is set to 000 by default, that which is 4 byte. Then hello interval, the interval at which hello packets are going to be advertised. What is the time of sending the hello packets? So generally by default 10 seconds for the point-to-point and 30 seconds for the broadcast link, guys. Okay. Then there is option field, and local router advertise its capability in its field. Then this is what going to be options. And then priority, the priority of the local router, it used for the election purpose, election of what? DR and BDR election. Okay, if it is set 0, the router is ineligible for the election. And if it is set to 1, it is what? Eligible for the election. Then router dead interval, this is what the dead interval, guys. And this dead interval are requested by the advertising routers. By default 40 seconds for the point to point and 120 seconds for what? The broadcasting. Then designated router is available, and designated router field is also the IP address of the current DR. Okay, it's set to 00 if no election has happened, right? Okay, so DR generally elected on the basis of some criteria. It is like a loopback address, priority, and then highest IP address. But initially it is set to 00 if there is no any election happened. Then backup designated router is also same. It is initiated to 000. Then if not election is happened 8. Okay, then neighbor, the router IDs of all the OSPF routers with whom the valid hello packets have been seen on the network. So this is what we can say the general format of the hello packet. And hello packet purpose is what we have discovered. We have taken only to check whether neighbors are working or not. Okay. Then second type of message is there. That is what data description message or link state database. That is database description message and working when router is connected to the system for the first time or after the failure. It means both the cases it is going to be first time. It need a complete link state database immediately. It cannot wait because it cannot wait for all link state updates packets to come from every other routers before making its own database and calculating the routing table. Therefore, after the router is connected to the system, it sends the hello packet to greet the neighbors. And this I in the first time the neighbor hear from the routers that they send the database description message. What is the meaning of this particular? At the first time, whenever the router is going to be connected to that network, or let's say after the failures, it required the complete information about the states available in the OSPF, but immediately they not get all the details initially. So it required to build the adjacency relationship with the help of hello packets, and then only it is going to be available. But in database description message, database description packet does not contain the complete information. Okay, there is one command, guys, show IP OSPF database available in packet tracer. We have implemented in the practical session, which show the details about uh, the database available with us. And this database description message only gives the outline of each line in the database, not complete information, only outline. And the newly connected routers examine the outline and find out which lines of information does not have. Okay, if any information is missing, that information can be demanded. It then send one or more links state request packet to get full information about that particular link. So if the data is missing, they can request to that particular information. When two routers want to exchange database description packet, one of them takes a role of master and the one will become slave. And what is the format available? There is a format available, guys. So here OSPF packet header format type 2. We are showing type 2. Then there is a one field, E field. This is one bit flag set to 1 if advertising router is at a autonomous boundary router, that is X stand for external. Autonomous boundary router. We know that autonomous boundary router is what? Autonomous boundary router, which helps to one autonomous system and other autonomous system. Then B flag is also one bit flag. It's set to if one if advertising router is the area border router. In case of the area border router, it is going to be set. I flag, it is initialization flag. It's set to 1 if message is first message. Then M flag, one bleed flag also there. The more flags it's set to 1 if there is not the last message. Okay. Then MS, that is master and slave. It if sets to 1, then master. It slaves to 0, then it is what? The slave. Okay. Then message sequence number. Then 30-bit, 32-bit field, guys. It contains the sequence number of the message, and it used to match the request with the response. Okay, whenever one sends the request to the other routers, then it matches whether that request has come from that particular requested node. If okay, then only the response is going to be available. Then LSA header. This is a 20-byte field used in each LSA. This header gives the outline of each links without details. It is repeated for each links in the link state database. So this is what the second packets available, guys. And the second packet is what? Database description packet, where the partial information is available about the states. Okay, there is no full information available with the states. Then there is a third packet, and the third packet is link state packets. Okay, the link state request. Link state packet is about link state request packet. Once the neighbor relationship or neighbor adjacency is formed, okay, and then database can be extended. The neighbor with whom the neighbors routers may locate missing database description information. They send the request packet to claim missing information to the neighbors. Receive this packet will give the LSU. Okay, after the hello packets, the relationship has maintained. Then what happened, that the database description table has been exchanged. But if any routers wants that I have the information which is very less, and some information is required to me because that information is missing with me, so that time this link state request packet can be sent by router 1 to router 2 to get the complete information, and reply to this particular link state request, the link state update message will be sent. Okay, this is what the meaning of this particular. Then there is a working simple work, as I told already, but this is what the packet that is sent by the router that need the information about the specific route or the routes. It can use by a newly connected routers to request more information about some routes after receiving the database description table. Okay, so whatever the missing information is there, that is demanded over here. Then there are some fields available in the header format. So here type 3 available, because we are discussing type 3. The link state type, there are 3 fields are link state type. There are 5 types of advertising links are there. One link, network link, summary link, network, then summary, link to the edge boundaries, and the external link. These are the 5 links are available. Okay, uh, only to request the particular nodes. Then link state ID. The value of this field depends upon the type of link. The type 1 is router link, and this is what the IP address of the router. For type 2, it is what going to be a network link. So this depends upon a particular link state type. Then advertising router. This is the IP address of the router advertising the message. The one who is advertising the message, as IP address is going to be available. So this is what the link state request message is going to be. Only when the information is missing with us, that router will send the request to particular other routers to get the complete information. Then this is what the fourth message, that is link state update message. This is what the heart of OSPF message, guys. Okay, we have shown, I have shown that type 4. The link state update message or packet. It is a response packet send a specific piece of database description information requested by other OSPF neighbors via LSR. So it is what the response to with the request message. Okay, how it works? It is the heart of OSPF operation. It is used by the router to advertise the state of the links. What is the current state of the link is going to be there, and that is going to be advertised. And the link state update packets are OSPF packet type 4. This packet implemented the flooding of LSAs at advertisement. Each LSA contains the routing matrix, topology information to describe the portion of OSPF network. So this is what the format available here, and this is what the update. This sends as a reply to that particular request made by any OSPF neighbor, and it comprises of the state information of all the available nodes. So this is what the core part of the OSPF protocol, guys. We have implemented in that particular packet tracer. Then the last packet is the link state acknowledgement packet. So this, the router that send the LSR, that is request packet, confirm receiving the LSU once we got the updated packet from the neighbor by sending the confirmation packet acknowledgement receiving that requested. Okay, so here only this is what the confirmation of that updated packet for that the request has made earlier. Okay, this is what the confirmation. Now how it is work? OSPF make routing more reliable by forcing every router to acknowledge the receipt of every link state update packets. It has the common OSPF header format and general LSA header. The two sections are sufficient to acknowledge the packet. So these are the only two sections are sufficient to acknowledge the packet. And single acknowledgement packet can include the response to multiple packets also. So this is what what we can show good gesture shows in front of whatever the updated message received by any OSPF neighbor that I have received, and this is what the acknowledgement to you guys. Okay, and this is what the header format. And there is a summary of all the links that packets. The very first is hello. Hello is what to discover the neighbors and build the adjacency. Then the database description, guys. Check the database synchronization between the routers. And third is what LSR request. That is our link state request. It requests for the specific link state record because this is which is missing to the DBA. Okay. Then it is what update. It sends the response to the request. So in this direction it is going to be work. And this request is in this direction going to be work. This will be the both direction we can say, and then acknowledgement is going to be in this direction going to be work. This is what the link state routing packets are available, guys. Then as committed, there is a second topic what we have for this part 2 is what the OSPF states. So there are 7 states are available. How this OSPF neighborhood relationship started from the down state to the full state. Okay, that is shown over here. The very first step is what the down state. Very first is what down state. In this state, no hello packet have been received by the interface. No hello packet have been received by the interface. It means what down state doesn't mean that the interface is physically down, but here it means that OSPF adjacency process has not yet started. Okay, so this is what the down state. And to show this, what we have a diagram, let's say, and in this diagram, what we say the first there are router 1, router 2, at time is showing the link between the routers comes up. Very first is a down state. They have not exchanged their hello packets yet. Okay, this is what the first state. Then we go to the next state, and that state is what any state. In this state, hello packets have been received from one router, only one side. Let's say if I am, let's say R1 is sending hello packet to R2. Okay, with router ID that is 1.1.1. Okay, this is what the init state. And then there is a third state. and that is two-way state. In this two-way state, both the routers have received the hello packet from the others, and bidirectional connectivity has been established. Okay, it means what? Then R2 has also sent the message, hello, I am R2, that is what my ID is 2.2.2. Okay, this is what the two state. It means what? The R1 and R2 both have exchanged their packets, hello packet to each other, and they have formed the hello greetings. Then fourth state, and this is two-way state, that this is the state between the two-way state and the XSTAR state for the DR and DBR BDR election takes place. Okay, then XSTAR state is available. In this state, null database descriptions are exchanged. In this state, master and slave elections takes place. The router having the highest ID become the master, and which other will become the slave. The election decided which router will send its database description first. This is what going to be happen over here in this X state. A router who have formed relationship with the text a part of this election. So here election is going to be takes place. The master and slave is going to be identified and decide who will be responsible to send this database description message. So here again, the X state is available for what the database description packet containing the LSA request, advertisement request. Okay. Then there is a fifth state is available, guys, and that is what the exchange. In this state, actual database description are exchange. Okay, so exchanging of the database description is going to be available in this particular state, guys, exchange state. And then there is a loading state. In this state, LSR, LSU, and LSA link state acknowledgement are exchanged. The request, update, and the acknowledgement is going to be exchanged. And very important, guys, and here, if you go with this particular term, when the router receives the DBD from the other routers, it compare its own DBD, general fundamentals, with the other router DBD. If received DBD is more updated than its own, then router will send a request to the other router stating that the links are needed. The links are needed, and the other router replies with the LSU containing that updates that are needed. In the return to this, router replies with the acknowledgement message. And general fundamental in routing, whatever the table what we have, if I have table and other also have table, and if I receive the tables from the others, guys, and if I don't have the information which is available with other routers, that information is what new to me. So that information is supposed to be accepted, and for that purpose I have to check whether do I have entry up to this, do I have entry of this. If no, accept it. If yes, reject it. So this is what the concept about this particular loading. Then the last step is what the full state. In this state, synchronization of all the information takes place. OSPF routing can begin only after this full state, and we have shown this full state also in our video, which is where we have demonstrated the OSPF single area and multi area also. After full state only, everything is going to be happening. So this is what the diagram of all the states that R1, R2, and I have explained to you. I hope, guys, these states are okay. And this last part of this particular lecture is what the different advantages and disadvantages of this particular OSPF protocol. Let's take the first advantages. It is the highest performance open standard routing protocol. As we know, there is no limit to connect any routers, number of routers, highest performance, and mostly it is going to be used for the largest network. It is going to support for the classless routing protocols. This is also advantages. It provides the open shortest path routing and fast route discovery and rerouting. If any route, let's say, get collapse, automatically there is a topological table is already available where the alternative path is available, and the reroutings and the reconfiguration is going to be very good and fast one, because file discovery is going to be very high. Then it consumes minimum link overhead when the network is in a steady state. This is also advantages. It has been certified by Internet Engineering Task Force and implemented by many vendors. Okay, so this is what the beauty of all the OSPF protocols, OSPF protocol. And there are some drawbacks are available, not drawback, but we can say the complexities are available. It demands the higher processing and memory requirement than the RIP. If this OSPF is going to be used in a very large network, so definitely the link state packets are going to be sent to across the network. If let's say router size and network size is 1000 routers, that time it is going to be very time consuming job. Let's say it required the more processing capacity, and it required the storing capacity also. They will consume the large bandwidth at the initial link state packet flooding. The flooding mechanism always consume the large bandwidth, guys, because unnecessary the packets received from one end to another end also, and it is difficult to configure than the RIP, guys. So these are the few complexity or drawbacks are available with this particular OSP protocol. So here in today's lecture we have discussed about the packets, then we have discussed about the states, and we have discussed about the advantages and disadvantages. So packets are more important, where hello packet is there, then we have database description packet is there, then request packet is there, then update packet is there, and lastly what we have acknowledge packet is there. I hope guys this video lecture is going to be understood by you. Thank you. Thank you so much.